Hi everybody, now today we will continue our lectures on integration, that means which is technique of integration. In these lectures we will discuss different questions with brief solutions, especially we use those technique of integration, that means integration by substitutions, integration by parts, and integration by partial fractions. Some of the formula are given here. The integral, for example, integrations. For example, integrations for to use integration for substitutions. That means if the integration is given in the form of the integral of f of g of x times g derivative at x dx, then by letting u is equals to g of x, then it becomes what? The integral of f of u du. And integrations by parts, the integral of u dv is equals to uv minus the integral of v du. In such a way that the integrations by partial fraction is also given. The integrations for general form for integration formula for integrations are given also here, and we will discuss such questions, how we can solve such questions and others within their solution. But don't forget to subscribe, like, comment, share this channel. Now this is a worksheet for question number 1 says that evaluate the following integral using algebraic substitution. A says that the integral of cos x dx over square root of 1 plus sine x. Now this can be solved by substitutions, and let us relate as u is equals to 1 plus sine x and du becomes cos x dx. Here we left dx here. So substituting all of those informations in the given questions, then we have that the integral of cos x dx over square root of 1 plus sine x becomes the integral of du over square root of u. Why this? Because du is which is cos x dx. Therefore, if du is cos x dx, then we substitute here, and the square root of 1 plus sine x becomes square root of u, because u is equals to 1 plus sine x. Again, this can be written as the integral of u to the power of minus 1 over 2 du. Again, by using the power form for integrations, this becomes, that means the integral of x to the power of n dx is x to the power of n plus 1 over n plus 1, where n is different from minus 1. So that the integral of u to the power of minus 1 over 2 du becomes u to the power of minus 1 over 2 plus 1 over minus 1 over 2 plus 1. But minus 1 over 2 plus 1 is 1 over 2, so that we have this is equal with u to the power of 1 over 2 over 1 over 2. Again, this can be simplified as u to the power of 1 over 2 over 1 over 2 means that 2 times u to the power of 1 over 2. But our u is 1 plus sine x, so by substituting u, we have 2 times 1 plus sine x the whole to the power of 1 over 2 plus c. B. The integral of 1 plus square root of x is the power of 4 over square root of x dx. Again, this can be also solved by substitutions. Again, and relate as u 1 plus root x. If u is 1 plus root x, du becomes what? 1 over 2 times square root of x. By rearranging this, we have that, or by multiplying both sides by 2, we have 2 times du is equals to 1 over root x dx. So substituting in the given equation, that means say for equations 1 plus root x, we use u, and dx over root x becomes, which is 2 times du. So we have that the integral of 1 plus root x power of 4 over root x dx is the integral of u to the power of 4 times 2 times du. Again, by taking 2 out of the integral sign, then we have 2 times the integral of u to the power of 4 times du. Again, using the integrations of power rule, then we have 2 times the integral of u to the power of 4 du becomes 2 times u to the power of 5 over 5. But u is 1 plus root x, then we have 2 over 5 or 2 times 1 plus root x to the power of 5 over 5 plus c. Question number 2. Evaluate the following integrals using integration by parts. A. The integral of ln of x squared plus 4 dx. Now using integration by part, by letting u, or by using the formula u, the integral of u dv is equals to u times v minus the integral of v du. So let us relate u as ln of x squared plus 4. So du becomes what? Twice of x over x squared plus 4 dx. And let us say our dv as dx. If dv is dx, then by integrating both sides, we have v is equals to x. Then apply integration by parts. That means the integral of u dv is equals to u times v minus the integral of v du. We have like this, ln of x squared plus 4 dx, because our u is ln of x squared plus 4 and our dv is dx, and then we have the integral of ln of x squared plus 4 dx. Then u times v becomes also what? Ln of x squared plus 4 times x, because our u is ln of x squared plus 4 and v is here x, therefore we have x times ln of x squared plus 4 minus the integral of v du. We have minus times, since our v is, which is x, and our du is 2x over x squared plus 4 times dx, and by arranging this we have that minus of 2 times the integral of x squared over x squared plus 4 dx. Therefore we have that the integral of ln of x squared plus 4 dx becomes x times ln of x squared plus 4 minus 2 times the integral of x squared over x squared plus 4 dx. Again, this x squared can be written as x squared plus 4 minus 4, so that we have x times ln of x squared plus 4 minus 2 times the integral of x squared plus 4 minus 4 the whole over x squared plus 4 dx. And by splitting this into 2, we have that x, this is the same as x times ln of x squared plus 4 minus 2 into, by splitting this, we have 2 into the integral of x squared plus 4 over x squared plus 4 dx minus the integral of 4 over x squared plus 4 dx. Again, by simplifying this and by rearranging, we have x times ln of x squared plus 4 minus 2 into the integral of dx minus 4 times the integral of 1 over x squared plus 2 squared. Why? 4 is the same as 2 squared, and we take 4 here, and we use, or this integral form has the integral of the form of the integral of 1 over x squared plus a squared dx. But the integral of 1 over x squared plus a squared dx is the same as 1 over a tan inverse of x over a. So to use that formula, we have here x times ln of x squared plus 4 minus 2 into the whole the integral of dx minus 4 times the integral of 1 over x squared plus 2 squared dx becomes x times ln of x squared plus 4 minus, by rearranging this, minus 2x plus 4 tan inverse of x over 2 plus c. Why here? Since the integral of 1 over x squared plus 2 squared is what? 1 over 2 tan inverse of x over 2. Here we have 4, therefore 4 by 2 is, which is 2. Then here we have minus, which is, we have positive 2, and the integral of dx is, which is x, then multiply by 2, we have finally x times ln of x squared plus 4 minus twice of x plus 4 times tan inverse of x over 2 plus c. Another is the integral of e raised to 2x times cos 3x dx. Again, this is also solved by integration by parts. Now, using integration by parts, let u as the functions which is easily differentiable, and for the time being, let us use u as e raised to x. Now, if u is e raised to 2x, our du becomes twice of e raised to x dx. And our dv becomes cos of 3x dx. So by integrating both of them, the integral of dv is equal to the integral of cos 3x dx. Then it becomes what? V is equals to 1 over 3 sine 3xy. Since here the integral of dv is v, the integral of cos 3x dx is, which is 1 over 3 sine of 3x, by using the formula, the integral of sine cos ax dx is 1 over a cos sine ax. And so using integration by parts, that means the integral of u dv is equals to u times v minus the integral of v du. And by substituting all of those information in this formula, we have that the integral of e raised to 2x cos 3x dx is equals to 1 over 3 e raised to 2x sine 3x minus 2 times, or minus of 2 over 3 times the integral of e raised to 2x sine 3x dx. Here we left dx. Again, this is also has integral form, so we should have to evaluate the integral of e to the power of 2x sine 3x dx. But this can be solved using what? Integration by parts. And we let us u as e raised to 2x. If you use e raised to 2x, our du becomes 2 times e raised to 2x. And dv becomes sine 3x dx. If dv sine 3x dx, our v becomes minus cos 3x over 3. And by taking all of those informations, or by applying integration by part, or by using this formula, the integral of u dv is equals to u times v minus the integral of v du. We have 1 over 3 times, and by using this, by taking all of this information, we have 1 over 3 e raised to 2x sine 3x minus 2 over 3, the whole into this the value for integral of this e raised to 2x sine 3x, which is minus 1 over 3 e raised to 2x cos 3x plus 2 over 3 the whole into the integral of e to the power of 2x cos 3x dx. Dear, these values, or these values in the closed bracket, is the value for the integral of e to the power of 2x sine 3x, which is solved using integration by part, by letting u is equals to e to the power of 2x and dv is equals to sine 3x. So that all of this can be simplified as 1 over 3 e to the power of 2x sine 3x plus 2 over 9 e to the power of 2x cos 3x minus 4 over 9 the integral of e to the power of 2x cos 3x dx. Again, we observe that here our required equation is, or our aim is to find the integral of e to the power of 2x cos 3x dx. But here we have also another integral e to the power of 2x cos 3x dx. Now, by taking here the coefficient on the right hand side which is 1, and on the left side which is minus 4 over 9. So by taking this on the right hand side, then we have that 1 plus this 4 over 9 the integral of e raised to 2x cos 3x dx is equals to this terms 1 over 3 e to the power of 2x sin 3x plus 2 over 9 e to the power of 2x cos 3x. So that means 1 plus 4 over 9, the integral of e to the power of 2x cos 3x dx is equals to 1 over 3 e to the power of 2x sin 3x plus 2 over 9 e raised to 2x cos 3x. But 1 plus 4 over 9 is which is 13 over 9, and this by multiplying or by dividing both sides by 13 over 9 on both sides, or by multiplying both sides by 9 over 13, then we obtain that the integral of e to the power of 2x cos 3x becomes, and by taking e to the power of 2x as a common, we have the integral of e to the power of 2x cos 3x dx is equals to e to the power of 2x over 13 the whole into 3 times sin 3x plus 2 times cos 3x plus c, or in other ways this can be equal with e to the power of 2x over 13 into 2 plus cos 3x plus 3 times sin 3x plus c. Question number 3. Evaluate the following integrals using integration by partial fraction. It says that the integral of 1 over x squared plus 3x minus 4 dx. Now this can be solved by integration by partial fractions. Now let us we check whether this the denominator x raised to 2 plus 3x minus 4 is reducible or irreducible. But it is reducible. Now using integration by partial fractions, that means let us first we find the partial fractions for this 1 over x squared plus 3x minus 4. But x squared plus 3x minus 4 is the same as x plus 4 times x minus 4. Therefore, we have 1 over x plus 4 times x minus 4. This partial fraction form of this becomes a over x plus 4 plus b over x minus 1. Now again this can be solved as a into x minus 1 plus b into x plus 4 the whole over x plus 4 times x minus 1. That means a into x minus 1 plus b into x plus 4 the whole over x plus 4 times x minus 1. Now x plus 4 times x minus 1 is cancelled by x squared plus 3x minus 4, or by this x plus 4 times x minus 4. Then we have left that 1 is equal to a into x minus 1 plus b into x plus 4. Now by rearranging or by writing the equal side of this here, 1 can be written as 0 times x plus 1. And this a into x minus 1 plus b into x plus 4 can be simplified as a plus b the whole x plus the whole into minus a plus 4 times b. And by equating with this 0x plus 1, we have a plus b is equals to 0, and minus a, this minus a plus 4b is equals to 1, and a plus b is equals to 0. So by solving this, we obtain a is equals to minus 1 over 5 and b is equals to 1 over 5. So substituting this in the given equation, therefore the integral of 1 over x squared plus 3x minus 4 dx becomes the integral of a over x plus 4 plus b over x minus 1. But by substituting the values of a and b and by integrate by splitting and by taking integral the inside side also, we have the integral of minus the integral of this, the integral of a over x plus 4 dx plus the integral of b over x minus 1 dx. But our a is minus 1 over 5 and the b is 1 over 5. So we have the integral of minus 1 over 5 times x plus 4 dx plus the integral of 1 over 5 times x minus 1 dx. Now this can be written as the minus 1 over 5 the integral of 1 over x plus 4 plus 1 over 5 the integral of x minus 1. And this can be simplified as minus 1 over 5 ln of x plus 4 plus 1 over 5 ln of x minus 1 plus c. Thanks for watching my video. If you have comments or if you have any questions, write on the comment. And if you love this tutorial, please like and share to your friends, and don't forget to subscribe if you are not subscribed before.